real quick because the warm-up problems are going to help you on the problem that we're working on today. Okay, also, did everybody receive one of the handouts? Who did not get a handout? Okay, so let's start with real quick with the warm-up. Okay, so solve these equations. Now, number one looks a little strange because we've been focusing mainly on one variable equation, and as you notice, that one has two variables. But if you studied the problem real quick, you would be able to understand it and be able to solve it. So, who did number one on the warm-up? Okay, Rudolfo, read the problem.
Two x plus 2x equals 8.
So what is x? What is the
2?
2. So now do you see why you would replace 2 with a variable? Or you would replace the variable with the 2? Because why would you do that, Rodolfo?
Because 2 times 2 equals 4, and then 2 times 2 equals 4, and 4 plus 4
equals 8. So did everybody understand that?
Yeah.
Okay. Okay, number 2. Who did number 2? 3x equals 90. Okay, Daniel?
X equals 30.
X equals 30. So how did you get 30 as the answer?
Because I divided 90 into 3.
Or actually, should be the vice versa. 3 into 90. So you see that? Remember, when you're doing adding, a lot of times you're doing the opposite of adding, which is subtraction. Also, when you're doing multiplication, a lot of times you're doing the opposite of multiplication, which is dividing. So he divided 3 into 90. Okay, number 3. 5 plus x equals 98. So what is x? Who did number 3? Okay, Lisuli?
X equals 93.
X equals 93. And how did you get x equals 93?
I subtracted 5 from 98.
So she subtracted 5 from each side. So 5 take away 5 is 0. 98 take away 5 is 93. And then the last problem, this one I made it a little bit more trickier. 15x minus 10x equals 25. So what would x be? Did anybody get a chance to solve? Okay, Rodolfo?
Equals 5.
X equals 5. So let's take a look at that problem. 15. So if you replace x, 15x, and you replace the x with the 5, that would be 15 times 5. And what is 15 times 5?
75.
75. Take away 10x. So if you replace the x with 5, what's 10 times 5?
50.
50. So you would have 75 take away 50 equals 25. So x equals 5. Okay. So hopefully you had a chance to look over the problem. I made a copy for you guys because what you're going to be doing is first you're going to go over this problem. What I want you to do, what I actually wanted you to do was read it on your own first, go over the problem real quick, and then after you had a chance to read it, then we're going to discuss it as a group. Okay, so take about a minute. So where it says there are 7 people on an elevator, take about a minute to read that part of the problem. Just read it to yourself quietly. Okay, let's just take like about 30 more seconds to finish up. Okay, now let me go over the problem now that you had a chance to read the problem. So let me read it for you. There are 7 people on an elevator. The elevator can hold no more than 1,000 pounds. An average student weighs 90 pounds and an average teacher weighs 150 pounds. how many students and how many teachers might there be on the elevator? So, first thing that we have to do is we have to look at the problem and, like I stated before, analyze the problem. See what the problem is asking us. So, Ronald, what exactly is the problem asking? So, what is actually the problem asking now? There's a bunch of information in this, but what is it actually asking you to do?
How many people are in the elevator? Like,
But is it just how many people are in the elevator? What is it specifically asking you? Let me have Jasmine help you out a little bit.
It's asking you how many people can fit in the elevator without like making it bust down.
Without what?
Making it bust down or going over the capacity.
And what is the capacity?
1,000 pounds.
1,000 pounds. Now it's not just asking you people. What specifically is it? Is it just any people? What is it specifically asking you, Kanaya?
teachers?
Just teachers? Teachers and students. So it's specifically asking you the elevator, the maximum capacity, which means the maximum weight that you can have is 1,000 pounds. Now it's asking you if a student weighs 90 pounds and a teacher weighs 150 pounds, how many students and teachers can you actually have on the elevator? So what we're going to do is we're going to try to solve that problem. We're going to try to see how many students can we put on the elevator and how many teachers can we put on the elevator without it being over 1,000 pounds. So the first thing, what do you think is the first thing that we're going to have to do based on what we just did earlier? Yes?
Multiply.
No, I mean, what type of problem would this be? What are we working with? It is algebra, but what specifically are we working with? Do we know every part of the problem? Yes. An expression. So we're working on an expression. An expression with what?
Variables.
With variables. Now, do we know how many students we can fit yet?
No.
Do we know how many teachers can we fit?
No.
So how many variables are we going to be working with on this problem? Two variables. You're going to be working with teachers and students. So what's a good way that we can write, or what are good variables we can write to signify teacher and students? So T for teachers
And S for students.
and S for students. Okay. Now, the reason why I moved some of you to other tables is because you're going to be working on this problem as a group. Exactly. So, what I want you to do now is come up with an expression with two variables to solve the problem of how many students and teachers can fit inside an elevator with a capacity of 1,000 pounds. Yes? Well, that's a good question. That's what you're going to try to find out too. You're going to try to find out, are you going to actually have exactly 1,000 pounds of students and teachers in the elevator? Are you going to have less? Now, can you have more than 1,000 pounds of students and teachers on the elevator? No, so right away you'll know that if you come up with that, is that going to be a good answer?
No.
Okay? So those are things that you should think about when you're working on a problem. Now remember, you're going to work on it as a group. So even though you're working on a group, I want everybody to have their own piece of paper. So I mean, you can all help each other out, but I also want everybody to show the type of computation or the type of expression with variables that you have, and your whole group can have the same expression written. So are there any other questions? Okay, so there's no other questions. Go ahead. So start working with your partners. In other words, there's a chance for you to talk to your partners, discuss different strategies, how you would solve this problem. Good? Okay. Now remember, we went over different methods in class roughly about a few weeks ago as to how you can solve expressions with variables. Remember, you don't just have to talk to the person sitting next to you. You can talk to anybody in your group.
How much students? We have 4 students and 3 teachers. 3 teachers.
You're going to be there for first and second period.
So if we multiply.
So again, as a reminder, in fact, I'll put it up on the board just so you don't forget.
90 times 7. But there's 7 people. So multiply. And 90 is the students, and 150 is the teachers. So how do you call one teacher and 6 students? One teacher, about 6 students. I think it should be like around here. Because with 206 students, it should be 2 students. 2 teachers and 5 students. You want to do that? Yeah. All right. So 5 teachers, 5 students and 2 teachers. So 9 times 5 and 150 times 2.
Okay, so on the board I put up, you as a group come up with an expression with 2 variables to solve the problem. Now you might, at your group, there might be like 2 different ways of solving it. That's okay. If one group has one way or if one person has one way and other people have another way, that's still okay as long as you at least agree with yourself or as a group that this is the way that you want to come up with, this is the expression that you want to use to solve the problem. Then the second part is to solve the problem using the information that you came up with.
5 teachers, 2 students.
Okay. So, are you guys all working together or are you coming up with different types of ways? Together? Okay, good.
We're working together.
Okay. How about this group? Are you guys trying to solve it in trying to make your own different ways or are you guys trying to agree on one? Okay. Okay.
If you try and a student, it will come up to 1,080.
Okay.
So which made it 10.
Okay. But remember, the thing is also that I want you to kind of like be able to show me how you came up with that expression. Okay. How about this group? Are you guys like coming up with 2 different types of answers? Okay. So wait a minute, 2 students is how many is 2? Each student is 90, right? Okay. But I mean, are you guys trying to stick to one thing, or are you guys all coming up with your own different? Okay. Are you guys? Did I ask? Are you guys trying to stick to one system, or are you guys doing your own different systems? Are you guys trying to solve it different ways? Okay. Yes. Okay. 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 So hold on, because again, in a little bit, I'm going to be asking some people to show me how they came up with their solution to the problem. Yes. It can't. Well, I mean, if it's more than 1,000 pounds, the elevator won't work. But remember, that's the most. That's for you guys to decide. I mean, it can be, or it can be less. It can't, but can it be over? Okay, so as long as it's not over, then that's fine. Yes. Okay. You're gonna have to go take that. Yes.
So we want as we're here.
Okay. Okay, and in fact, I'm going to write another little note because I'm noticing walking around that there's certain types of computations that people are using to solve the problem. So remember, if I call up somebody from the group, I basically want to know is how did you not only solve the problem, but what type of computation you use to solve the problem. Like I'm noticing a lot of people are doing different types of adding, dividing, multiplying, even some subtraction.
How much? 1,000. Or how many? I got 7, 150 cost. Okay. And 9 times 5. 7 gets to 7, make 7 to 10. And then put 1, 7 from here. Subtract 7 from 3. No, you can't do that.
Okay, well that's so I want you to I'm going to call on you guys, so I want you guys to explain that to.
Okay, can we do it?
You do. Let me see what you. Okay. Okay.
Are you getting phone?
What was it again that you guys came up with? How many students? And then what did you guys come up with?
5 teachers and 2 students.
Okay. Okay, let's spend about another 5 minutes finishing up. And then I'm going to ask some of you to come up to show me some of the ways that you use to solve the equation.
450 plus 540 equals 990. You go, I did 90 to 6, 540, I did 90 to 7, 630, got added. 450 to 630, got stacked, got added. 450 to 50, got 990. What you get? If you go over, it's gonna be sort of that. How did you do so many steps? How did you do so many steps? I did 956, but it got 540 and added 540 to the 450 and got 9,090. Then I added that one higher to 90 times 7. I got 630. I went 450 to 630, got 1,008. But it only weighs 1,000. I know it's not supposed to be. I did 9 times 6. I did 155 square, got 440, kept that. I did 9 times 6, got 540, then add those together, got 990. I got 990. That's what I got 2, but only 6 steps. Yeah, I know. I got 1,140. Yes, let's try 60 to 60. Try that times 9.
Wait, who? Okay, yeah. Wait, times 550, it'll be a little bit more. Because 5 teachers is 750, and 2 students is 180, so you have to add 750 plus 180. You just gotta be a little bit careful in the when you're computing problems. Yes. You guys are done? Okay, so this group is pretty much done? Okay, let me just go around checking before we start. Is this, oh yes. Is this group, are you guys almost? 4 to 100. What's 4 quarters? So what's 1 quarter?
10%.
So how many times does 4 go into 100?
5 times. 40.
You just said it.
45.
No, 25.
So that's
Okay, so let's finish up in the next few minutes. Yes. Does it have to equal 1,000? No. I mean, if you can solve it, where you can get it as close to 1,000, but remember, if it's over 1,000, is the elevator gonna move? Will the elevator move? Like, if the capacity of the maximum weight is 1,000, would it move if it's 1,100 pounds? No. So you have to. You can come close, but you can't go over that amount. Yes. Okay, well. Okay, yes. Okay, just hold on. I'm just giving people a chance to finish up. Yes.
He said it could be like.
Yeah, that, just some form of expression.
It could be like 1/10, something like that. Can it be 1/10?
Oops, let me check. So are you guys almost done? Okay, good. Okay.
So I actually.
Now, one thing I do see is, even though some of you are sitting at different tables, I do see like some people at different tables are coming up with similar ways of solving the problem. Yes.
I got a total of 99.
Well, Remember, the only thing is that it can't be over 1,000.
Because I got 150 times 3, which is 450. I got 90 times 6, which is 540. And I add those together, I got 90.
Okay. Yes. Did you have your forms? Okay. Okay, just actually just follow along. Just go to that back table and just follow along with them. Okay, this table, you guys can go ahead and continue working. Okay, and then the rest of the tables, 1, 2, 3, 4. Okay, the reason I'm kind of like stopping right now is so that I'll give it enough chance for everybody that wants to come up and show. And again, I've been noticing by walking around, I've been noticing that a lot of people are coming up with the same types of way of solving the problem. So, let's see. Let's start with the back table. So, did you, first off, in the back table, did you guys come up with the same expression for solving the problem, or did you come up with a different way? Each person. Okay, so then one person from that table could come up. Okay, go ahead. Okay, so everybody else, other than the table in the back right-hand corner, you guys are still trying to solve the problem, right? So other than that table, everybody else should be focused up here. Hold on. Okay, let me just recap the problem. There are 7 people in an elevator, and the elevator can hold no more than 1,000 pounds. An average student weighs 90 pounds, and an average teacher weighs 150 pounds. How many students and how many teachers might there be on the elevator? Okay. Oh, actually, before you explain the problem, Kanaya, first off, now remember, we came up with 2 variables. What was the variable that we came up for teachers?
T and S.
T. Okay, so put T and S up there. Put T on top and then S right below T.
Right here?
No, actually, move it a little bit more on your left-hand side. No, keep moving right next to the right. No, actually, you're right. You're right. I'm sorry. I'm giving you wrong. No, you're right. Move to the right. Here, let me go this way. Right over here.
Huh?
Yeah, right there. Say so. Write T equals, and then right below it S equals. No, right below it. Okay, so teachers, what would T equal then in this problem? What is T going to equal? But actually, what will T equal? What did we, or I don't know, did we actually go over what T would equal? It would equal teacher, so what would it equal? 150. Because remember, each teacher weighs, so right next to T, 150. And then S is for students, so what would students, S equals 90, okay? Okay, so explain to us how you came up with, or how your group came up with this solution.
We just did 150 times 3, then equal 450. But then if we only did 5, it wouldn't be enough, so we just added one more student and then 540, then we added together 990. But if we would have did higher, then it would have been over 1,000.
Okay, so basically, you came up with how many teachers and how many students? How many teachers did you come up that could
3.
3, and how many students?
6.
And what was the second part of your explanation why you had to stop there?
Or else, if we had did more students, it would have been higher than 1,000.
Okay. Okay, so did everybody see how that group came up with that problem? Solution to that problem? Okay, was there any other group that came up with the exact same way? of solving that problem? So your group also came up with it that way? Everybody at your group came up with the same way of solving it? No? Okay, please, unless you're being called on. Okay, so this group over here, Miney's, did you come? So you came up with the exact same computation as you came up with the exact same answer, but you came up with different amount of students and teachers. Okay, so if you came up with different amount of students and teachers, go ahead and up there and show us, or one of you from the table, go and show that you came up with So you came up with the exact same answer, except you had different amounts of students and teachers. Is that correct, my niece? Okay, go ahead. Okay. Here, let me. Okay, so they did actually come up with the same answer, so 990 weight, which is 10 pounds less than the full capacity. But what did you guys do different, my niece?
The problem.
No, but I mean, what's the difference? So, what's the difference compared to your problem? Even though you came up with the same answer, what do you notice is different?
Our problem, the Canadian problem?
Yeah. The answer is the same, but what is different? So, for example, is there a difference in teachers and students?
And students.
Or in both, or just in students? So what's the difference? Like, for example, how many students did they have in their problem? No, I mean in their problem. Look back at Kanaya's problem. How many students did they have? 3? 6. So if you notice, 90 times 6. And how many students did you guys come up with?
6.
You guys came up with 6? Do the students weigh 150 pounds? How about somebody else from the table? Well, what was the difference, Anna, between yours and the back tables?
We saw that there was only 7 people, so we did 6 teachers and 1 student. That equals 7 people.
Okay. Well, see, that's both ways are pretty good ways of thinking about solving a problem, but they actually really analyzed the problem, and they said, okay, if there's 7 people on it, we're going to just come up with a maximum of 7 people, and then that's the way they solved it. They had 6 teachers and 1 student, and they actually came out with almost the same type of a way of computating it, and with the same answer as the back table. Okay, good. Okay. This table, did you guys come up with a different way? Well, did you come up with the exact same?
We came with this answer, but not the way they did.
Okay. Well, see, if you didn't come up with the same way.
They said the same thing.
Okay. Well, still, I want you guys to come up. So.
We did the same thing.
The exact same thing?
Yep.
All right. So how many? So you came out with 6 teachers and 1 student?
Yep.
Okay. Well, like I said, that's still good. That means that let's see, this table and that table came up with the same way of computating the problem.
Yep.
So I mean, that's not like what you were saying. It's not that they did something different or anything. It's just that you guys were all thinking alike. So there's nothing wrong with solving a problem the same way as somebody else solved the problem. Okay, the back table over here, did you guys come up with a different way? And actually, in the back table, there was 2 different ways of computating the problem. Ashley and Nitsi came up with one way, and then Paul and Ricardo came up with another way. So let's see, let's have Nitsi and Ashley come up. and show us the way they solved it. But see, again, the thing that I'm trying to focus on with everybody here is, even though a lot of times when I was walking around, a lot of you had different ways of starting out to solve the problem, and then a lot of you ended up coming together and solving the problem the same way. The thing is that what I noticed that a lot of you were sitting there discussing it and analyzing the problem. You were not just starting off with the problem and thinking, let me just write whatever. You actually sat there for a few minutes, discussed it amongst your table, and tried to analyze different ways or use different tactics of solving the equation or the expression with two variables. Yeah, just there you go. Okay, so go ahead and explain how you came up with this solution. Okay, I need everybody's attention right now.
Like there are 7 people, we got 5 teachers, and we times it times 5, and then like there's two people left, so maybe as students and 8 people beside.
Okay. Wait, could you? I didn't actually hear the last part, and if I couldn't hear, probably everybody in the back. So just explain it, the last part again.
Like there's 2 people left, so we made it as students, and we times it times 7 times 2, and then times 5.
Okay. Okay. Good. But actually, if you guys could just stay up there real quick, because the only thing is that. It's not like to criticize, because that's a good way of coming up. It's just like, remember in the computation you have to be careful, because like when you did 150 times 5, is that 750 that you came up with? Is that okay? And then you said you added 2 more students. Is that 2 students? So each student is 90 pounds. So how much would 2 students be? 180. So if you had 750 plus 180, how much would your total be? So, go ahead.
30.
Okay, go back up on the board, Nitsi. So let's just go back a step. So you see where you had 750? Okay, so go put 750 plus. Okay, and then how many students?
2.
So 2 times 90 is what? Okay. Okay, that's all good. I just wanted you to just recheck your work, because a lot of times, when we look at the work again, we're able to look at our problem. If there's some type of mistake in the computation, we're able to go back and check it. Okay, and now Paul and Ricardo. And while they're doing that, with the back group, were you guys able to come up with a solution? Okay. So now the way that they started out, they had t equals 150. So they did 150 times 3. So Paul, the 3, what does that mean? What does that mean? 150 times 3.
150 times 3, that means we times 3 by the weight.
So what does 3 mean? What does that signify?
The teachers.
The teachers, okay, so they did 3 teachers. Okay, and then the next one, 90 times 4. So how many students did you have?
4 students.
4 students. So as you can see with their computation, they had. Or actually, let me let you explain it. Go ahead.
Alright, we picked that there should be more students than teachers, because like every field trip that you go on, there's always more students. So then we just did 4 times 90, and that gave us 360, and 150 times 3. That equals 450. So we added it, and it equals 810.
Okay, so as you notice, see, they came up with a little different idea. Their feeling is that normally on a field trip, you normally will have more students than teachers. So again, that was another way. And then their answer was a little bit different from everybody else, just like the last group. They came out with 810 pounds. Okay, so last group. Hey, bring your paper up too, just in case you need to refer to it. Let's see, do you need more space? Okay. Okay, go ahead. Okay, so let me see. Let's see. Rudolfo, what is one method that you've noticed that throughout all the ways that everybody has solved, what is one type of computation that pretty much everybody has used to solve the problem?
Everybody has different answers.
But not only different answers, what is a type of computation they use to solve the problem? Multiplication. Good. So that was one way. And then Tierra, what was another way? Was there another way that people did? Not only did you multiply, what was the second part of the solution that people did after they multiplied teachers and students?
Division. No.
Close.
Oh, addition.
Addition, good. Okay, so actually this is a different system. If you want, you can move that up a little bit. Yeah. Actually, it's not gonna. Okay. So actually, this is the first time out of all the people going up there that I've seen division being used. Okay, add the zeros. Okay, so what I need you to do is explain it to us for a little bit. So go ahead, Jasmine.
We had to add teachers and students together, and we got 240. If they divided it into 1,000, so we took away the zeros.
Just a little bit louder.
We took away the zeros,
Mm-hmm.
and then we put divided by 100, and we got 4. We raised it 4, and we had to add the zeros back.
Okay, so how many students and teachers did you come up with?
40.
40? Okay. Does anybody, or can anybody like kind of help them out as to maybe why that might have been not, let me see, what's the good way of saying it? Maybe they could have used a different approach to it. Is there anybody out there that could give them advice? Yes, Tiara.
Y'all should never did division. You wanted to 24 to 100 because it wouldn't never be equal and what you call it? I forgot. When you supposed to use 7 people with I forgot.
Okay, a little bit. Let me try to. What she's actually trying to explain a little bit is about probably the method that you use. You know, like what everybody else tried to use is like the 7 people. And what she's saying is that the way when you divided the 24 is that, you know, Where did you get the 24 from? Where would the 24 come from?
Because you added the teachers and schools weight together.
The weight together. 24 pounds? 240, okay. See, that's probably doing it that way was probably not the best way to do it. Best way to do it was probably to kind of like solve them. Remember, since we were solving for two variables, so it would have been better to keep them apart. Okay, Kanaya.
I didn't get, like, what zeros did you add? How did it come up to 1,000?
Well, see, what she's saying is that since the weight was 1,000, what they actually did is that they came up where she got 150 for a teacher, 90 for a student. So if you add 150 and 90, that comes out to 240. And then what she did is she divided 240 into 1,000. And probably the only thing is that with the computation where they came up with 40.4, actually it should have been 4 with the remainder of 40. So in a way, that could have worked out if it would have been adjusted in a different way. But again, by adding both variables together, it kind of made it a little bit more confusing. Okay, thank you. All right, so are there any questions? But again, as you can see, there were different ways of solving this problem. Various different ways of solving it. In a way, even this problem right here, if it was adjusted a little bit more, you still might be able to come up with a solution to the problem. But again, as you saw, there were like 3 or 4 different ways of solving the problem. So again, when we work on various types of expressions, various types of problems with variables, hopefully you'll understand that a lot of times when you sit there and analyze it and try to find different ways of trying to solve a problem, you're going to be able to come up with a problem, and it may not be exactly the same way as your neighbor, but you're still developing that sense of analyzing, writing, and solving expressions with 2 variables. Okay, so any questions? Okay, good. Let me, I'll assign you with, yes.
I would get when we first did it, the first, the do now. I didn't get it.
You didn't get the first one? You mean like the 2x plus 2x equals 8? Okay, let's say, remember, when you have a number next to a variable, what type of computation are you going to be doing? Are you going to be adding, subtracting, multiplying, dividing?
Can't see it.
So when you have a number and a variable right next to it, multiplying, okay? So you could understand that 2x and 2x, you're going to be finding a number that you can multiply with, right? Now, as part of the solution, x has to be the exact same answer. So whatever answer you have here, you would have here. So now, again, there's various ways of going about to do that problem. Okay, one way could be, for example, if I was to divide this 2x into 8, how many times does 2 go into 8? 4 times. So then your problem would have 2x equals 8. So if you divide 2x equals 4, I'm sorry. If you divide 2 into 4, how many times does 2 go into 4? 2 times. So let's replace x with the 2. So what's 2 times 2? 4. And then what's 2 times 2?
4.
So 4 plus 4, is that equal to 8?
Yes.
Okay, so remember, in an equation, both sides have to be, as part of the equation, what do both sides have to be? What did somebody, I didn't hear that person? Equal. Okay, so any other questions? Okay, good. I'm going to assign you homework. I just have to actually look inside the book, our homework book, and I'll assign you the page during science class. Oh, you have a question?
What homework from last night?
The homework, I'll collect that in a minute. Yes. Yes. Okay? Okay. Okay, go ahead and clean up.